Good afternoon, everyone, and welcome to today's webinar, Stay Cool When the Grid Fails, How Solar Can Keep Your AC Running During Heat Waves. I'm Melissa Dinello from A1 SolarStore, and today we're bringing together two areas that are becoming increasingly important for homeowners, which are energy-efficient cooling and reliable solar power. I'm very excited to be joined by representatives from MrCOOL and SolarSpace. MrCOOL brings expertise in high efficiency, DIY-friendly heating and cooling solutions, while SolarSpace brings the perspective of a solar panel manufacturer and the technology behind the energy generation that can help power those systems. The reason we're bringing these two perspectives together is simple. During a heat wave, your air conditioner may be working harder than almost anything else in your home. At the same time, that's often when solar panels are producing significant amounts of electricity. So today we're going to explore how these technologies can work together to reduce cooling costs, increase energy independence, and potentially keep your home comfortable even when the grid goes down. We'll talk about why electricity bills spike during extreme heat, why solar production and AC demand can actually complement each other, what a DIY-oriented MrCOOL and SolarSpace setup can look like, what it takes to operate cooling equipment during an outage, and whether making these investments before the next summer heat wave makes financial sense. So we'll also leave time at the end for your questions. Please feel free to submit them throughout the webinar. You can leave them via chat. So let's start by having each other of our guests briefly introduce themselves. On the MrCOOL side, we have John Tucker, Product Development R&D. We have also Shane Hook, Product Specialist, and Chase Kendall, Account Representative. So team, could you introduce yourself, tell us a little bit about your role at MrCOOL, and give us a little bit of background on your experience in the HVAC industry? I don't know who wants to start.
My name is Chase Kendall. Go ahead, Shane.
So yes, I'm Shane Hook. I've been with the company for 4 years now. I'm National Sales Representative and Product Specialist for MrCOOL. A background in, grew up in contracting and building houses. Never had HVAC, but when we saw the opportunity with MrCOOL to be in more specialized, so I've been there ever since.
Amazing.
Okay.
And guys, go ahead.
Okay, my name is Chase Kendall. I am the account manager here for MrCOOL. I've been here for 2.5 years roughly, and that's what I do. I'll be your point of contact whenever you get ready to place orders.
Perfect. John, we're waiting on you.
My name is John Tucker. I have been doing technical support for probably about 14 years for MrCOOL, 22 years altogether. I work in the research and development department. I install units and see what we got, if we have any issues that we need to get fixed. And I'm in contact with the tech support team at all times to, help any problems out there as well.
Amazing. Perfect. Thank you and welcome. Thank you for being here. Now on the SolarSpace side, we have John Van, manufacturing expert of PV cell and module at SolarSpace. So John, if you don't mind, could you introduce yourself, tell us a little bit about your role at SolarSpace, and give us, some insight in the solar industry.
Hi, everyone. My name is John Van. I've been in the solar industry for over 15 years. SolarSpace is a manufacturing company. I've been with them for 3 years. So we're one of the top manufacturers in the world. We have over 55 gigawatts of cells and about 8 gigawatts of modules in the world.
Amazing. Perfect. Good to know. Now we're going to the root of the problem, which are heat waves, electricity bills, and outages. So if you guys don't mind, let's start with what homeowners are experiencing at the moment. These are questions a little bit more directed to MrCOOL. So if you guys want to chip in. But first, why do electricity bills increase so dramatically during heat waves?
I'll go ahead and review this one. It's easy because it gets hotter. During heat waves, it's a lot hotter outside, so your systems are having to run a lot harder than what they normally would during any time of the year. That means they're starting a lot more often, especially if it's an older system that's not a DC inverter. That hard start to just regulate that little bit of temperature that you're wanting to keep it at inside can definitely cause spikes, and they'll multiply throughout the day, of course, cause multiple increases in your electricity usage.
Okay. And how much of a typical home summer electricity consumption can come from the air conditioning alone?
There's not one percentage that you can put because every home is different. But
Okay.
one thing that you can guarantee is that your HVAC is going to comprise 40% of your electrical usage over the course of the year, on average, nationwide. And so that's an absolute guarantee. If you're able to, we can't say, some people want to suffer more through the heat than others do. So we can't give an exact percentage, but what we do know is that it takes up a large chunk of your usage regardless of the time of the year that it is.
Okay, understood. And remember, anybody at Mr. Cool, even John Van at SolarSpace can answer. This is for everybody, but why does extreme heat also create a greater concern around grid, reliability and outages?
Yeah, it basically take a whole strain on the grid system. So that's why a lot of these utility companies are having these, peak hour usage. They really want you to limit the usage throughout the day.
Okay. Okay, fair. And yeah, go ahead.
I would say when demand is high and reserve capacity is limited, of course, equipment failure or other disruption is harder to absorb. So utilities may request conservation or use controlled outages, in certain cases.
Understood. And now a little bit more directed to SolarSpace and to John specifically from the solar side. What are you seeing in terms of homeowners becoming more interested in energy independence and backup power?
Yeah, a lot of these places are having a lot of outages as well. So you want to be able to generate a net zero. You want to be able to use the consumption and know how much you consume and how much you output. So that is the one thing that a lot of people are, grasping on, is having control of their electricity and how much they're using.
Okay, so are homeowners increasingly looking at solar as more than simply a way to reduce the electric bill?
Yes, I think there's both side of it. Some states and some utility are even benefits you. They want to give you incentive, right? Other places just want you to net zero to basically just offset your usage.
Okay. Okay, fair. And before the webinar today, for the last couple of days, our team has been, gathering questions from our community. So basically, we asked some of the followers and users what questions or concerns they have when planning their solar and energy projects. For example, there was this question from one of our users that says, I'm looking to install a 612 kilowatt inverter charger in an outbuilding that is about 200 feet from the electrical service entrance, where the CTs would need to be. He has a 412V, 314AH batteries, and about 1,000 watts of solar panels. So he'd like to use the system for peak load saving with no feedback on the grid. So is running the CTs that far away doable? He asks.
Generally, yes. It really depending
Okay.
heavily on your inverters and charger. You want to be able
Okay.
to run the wire all the way there. And most inverters are hybrid now. So external CTs such as like SolarStore and other companies, they basically able to have a low voltage signal wiring and not just powering the wire, right? So distance is limit. It really depending on the amperage. So anything over
Okay.
200 feet, you want to think about the size of the wire.
Fair, understood. And another question, and this, then we'll leave it for the end if we have some questions for the audience. But one user asks, are soft starts required for inverter mini split air conditioners and heat pumps? This is more for Mr. Cool, I believe.
Yeah, John, I think that's probably a good question.
So I'm sorry, can you repeat that one more time?
Yeah, sure.
Oh, go ahead. Sorry.
No,
Tucker,
it's
for
just.
you.
Mm-hmm.
The inverters already have the soft start kits are already built in. They already start up as soft as they can and then ramp up to the high capacity, and then they will modulate as it needs it throughout the course of the runtime.
Okay. Okay, perfect. And now moving on to actually a success story we have on our side from A1 Solar side. Um, when A1 Solar CEO Alexei Kruglov installed solar panels and a Mr. Cool AC system at his Florida home, his motivation was simple. He wanted to practice what he preaches. He actually gave us this really cool like outline of I couldn't recommend something to a customer that I wasn't willing to live with myself. So he basically wanted to see whether the real world results would match the promises he heard in the industry. Um, so after the installation, he was especially impressed by how well the system performed through, Florida's intense summer heat while keeping energy usage and electricity bills down. The biggest surprise he had basically was that it wasn't just the savings, it was the satisfaction of personally using the products he recommends to customers and taking a meaningful step towards addressing climate and energy concerns. So he gave us a final advice to homeowners. He said, like, do it, go for the system, but go in with a plan. You need to understand the installation process, choose the right people to do the work, and set a realistic budget. So basically now moving on to questions. Um, this is more to John at SolarSpace. Um, so solar production is often highest during the same part of the day when AC demand is highest. So how significant is that relationship from a solar manufacturer's perspective?
Yeah, I mean, it's one of the most important alignment facts in residential solar. Peak
Mm-hmm.
solar output typically falls in the late morning throughout the mid-afternoon. And like the AC usually run about like in the, you know, late morning and afternoon throughout the evening. So in that setting, you're really overlapping and you're offsetting that usage right there. You don't really need a storage. So in that setting, whatever you're outputting, you're also inputting as well during that time.
Okay. Okay, and does the timing of solar production make cooling like one of the more logical loads to power with solar?
Yes, during the morning and afternoon, that is the best time actually to have your power generating and producing while you're using your offset. So basically, you want to think about a net zero aspect, right? You don't want to overconsume and you don't want to underperform.
Okay. And how does panel efficiency affect the amount of roof space a homeowner needs when designing a system to offset AC consumption?
Yeah, in that setting, you want to be able to have enough room space. You want to have, a site surveys come out to see how much you could basically put on your roof, right? You don't want to have higher wattage
Mm-hmm.
or under wattage. So you want to have enough space that can fill your roof at the same time have enough to have fire hazard and whatnot if the system need be automatically shut off.
Perfection. And what would your advice be for someone living in a particularly hot climate? What should they consider when selecting solar panels?
Yeah, you want to be look
I think we lost your audio, John, for a second. Can you
also
hear us?
for
Okay, now we have you
yeah.
back.
Oh,
I'm
sorry
so
about
sorry.
that. Yeah, so you want to be choosing places that have like a heat climate, but
Mm-hmm.
you don't want to be choosing a place that also have too much cold as well. So in that setting, you want to have enough that can cover the roof and the bifacial actually are better because they're able to distribute the heat throughout the cell and the other side to distribute the heat.
Okay, understood. And do extreme temperatures affect solar panel performance? And if so, how should homeowners account for that when designing their system?
Yeah, so it does play a factor. We want to have as much sunlight radiance as we can, but too much heat can also damage the system. You're overworking the system. Basically, you're not going to generate exactly what you want. So in that aspect, when you look for solar panels, you want to look for tier one modules. You want to look for the coefficient rating of their maximum power and output as well. So these are things that people should look for when they're looking for panels.
Perfect. That's a pretty good advice. And now moving it along to the Mr. Cool team, for whomever wants to answer. From the HVAC side, how does using a more efficient Mr. Cool system affect the amount of electricity a homeowner needs to produce?
Most of your older systems, like we said earlier, are based on only being on when they're required to be on, and that requires a lot of energy to be able to get that system to run. With newer DC inverter technology, whether it's mini splits or if it's ducted systems, the DC inverter technology allows it to be able to run on kind of a trickle charge. So that outdoor unit will always be running and ready to be able to change what degrees that you needed to accommodate for the indoor temperature. What that means is that you don't have those hard start requirements that the grid, that pulls from the grid to get that system up and running. So what it does is it runs at a way more higher efficiency level at that point. It's using less, fewer kilowatt hours to require that cooling that's needed.
Perfect, Shane. And also, can improving the HVAC efficiency actually reduce the size of the solar system a homeowner needs?
Yes, it can reduce that by once you improve the efficiency, you're not going to pull as much amperage and have to have that draw that you're going to need if it's a newer system.
Okay. Okay, so let's say someone is starting from scratch, and this question is basically for anybody that wants to grab it and answer. Should they think about their solar and cooling systems as two separate purchases or as one overall energy strategy?
From our side of things, we'd say you have to look at it both ways.
Okay.
They are separate systems. The HVAC side needs to be measured to make sure that you're accounting for the correct amount of BTUs that you need for each individual space that you need. That's going to translate over to what your outdoor condenser energy is going to pull from. When at that point, then yes, that solar is going to be coinciding with that based on what energy is being provided. But John, do you agree with that?
Yes, I totally agree with that. You definitely want to see how much energy you use. Therefore, we can design the system accordingly to energy efficient in your home.
Amazing. Thank you guys for that answer. And now, basically, let's get into one of the areas we've seen a lot of interest in, which is DIY. This is basically for the audience. If you're interested in a DIY solar or cooling setup, drop DIY in the comments so we can see who's considering this approach. So now to the Mr. Cool team. I hope you're cool that I'm calling you guys Mr. Cool team. So what makes Mr. Cool particularly attractive for homeowners who want a DIY-friendly cooling solution?
So the Mr. Cool products, the DIY systems themselves, are the only true DIY HVAC solution on the market. And so our patented technology with our pre-charge line sets allows for you to not have to require a licensed professional to do any form of installation. And so what that means is you're taking that now onto yourself. We always require, and ask somebody to hook up the electricity, to the disconnect to the web, just to make sure that's done correctly. But for the system itself, it is a DIY capable system. So you're able to step yourself through the installation manual and process to be able to walk right through and select everything needed to be done.
Okay. And what
I
does
think
a
we have the
homeowner?
video as well. I think there's a
Oh, we
video
do.
that you guys have a link to that you could either share. I think
do,
it's
and
about 5 minutes. So I don't know if we have time for the full thing, but definitely it does step through exactly what that process is.
Amazing. That's cool to hear. Ali, so if you can, I don't know, maybe, you can actually scan that and watch the complete DIY installation walkthrough. So that's a cool opportunity. And also to the Mr. Cool team, what does a homeowner need to understand before attempting a DIY Mr. Cool installation?
Well, definitely you're going to want to know what you're getting yourself into. That when we say it's DIY, it is DIY, definitely, but you have to be DIY savvy in the process just the same. There's requirements like needing to potentially drill a hole through the side of the wall to be able to gain access for your line set to run out to the exterior to meet your condenser. Sometimes that's the scariest part. And so making sure to understand where your build is, making sure your location is absolutely correct, and that everything is where you need it to be. And of course, once again, reading that install manual, watching the videos, familiarizing yourself with the product to make sure that you can take on that.
Perfect. And we actually have the first question from the audience. They're saying, can you talk approximately the minimal power required to power a whole home AC system versus an individual room AC?
Could you repeat that question again?
Sure. Can you talk approximately the minimal power required to power a whole home AC system versus an individual room AC?
An individual room AC.
Mm-hmm.
So what you're looking at about roughly 45 amps at 230 volts. To down to if a room AC, you're looking at maybe 15 to 20 amps at 240 volts or 115 volts.
Mhm.
Okay,
That's right.
perfect.
That's right. Yeah.
I hope that answers the audience question. So now I have another one for Mr. Cool. What are the most common mistakes you see homeowners make when approaching a DIY HVAC installation?
Making sure to size it properly. Size is important for the location. That's probably one of the biggest things you want to make sure that you do get correct. Everybody's space is different. Most of the guides that you can find on places like our website or through our partners would recommend certain sizes based on regular ceiling heights that are in residential homes, 8-9 foot ceilings. But in the event that you have a larger space that has maybe vaulted ceilings, or if you have multiple rooms that you need to account for in spaces, maybe it's a conjoined living room and kitchen, you may want to step up in size to be able to accommodate for that extra heat that may be coming if you cook a lot. So just making sure to know the layout of your home, understand what may be required for heating and cooling, and be able to pair that correctly is the most important thing.
Perfect. And John, now from the SolarSpace perspective, what should a homeowner know before attempting a DIY solar installation?
Yeah, you want to be able to look for the tier 1 module. You want to know how much room you have on your roof as well. And on top of that, you want to know how much square feet and what energy you're using. So it really comes back to the kilowatt usage, right? So in that setting, know how much you use, and then after that, then we can calculate exactly how much to produce for that home and that system.
Okay, and let's say that same person, does he need to, or do they need to consider any particular, restriction or something of the sort when selecting solar panels for a DIY system compared with maybe a professional designed installation?
So when you think about DIY for a solar system, right, it's basically just assembling, because when you're thinking about turning it on, you have to have interconnection, you have to talk to utility, you have to make sure you are basically, wired correctly. Because if one little faulty, that system could catch on fire, or have one little faulty can also, underperform. So there's a lot of settings with that. You want to basically know exactly the spec sheet and what you're dealing with. So in that setting, you still need an engineer to help you design the system. Therefore, you can get the proper output you want.
Perfect. And taking that into account, how important are panel specifications such as wattage, voltage, current, and physical dimensions when designing a DIY system?
Yeah, I mean, most of the residential homes are, anywhere under 400 to 450 watts. So anything above that, it basically needs more room, right? Because it's bigger. And in that setting, you won't have as much room on the rooftop. But if you do a ground mount, you can have any wattage you want. Doesn't matter, 600, 700. As long as you have the room, you're able to design the system accordingly through wattage and size of the panels.
Okay, perfect. So guys, taking into account all of your, yeah, John, go ahead.
I was just going to add to that is what I've noticed on our dealing with the solar that I have is getting with the RECC, your power company, make sure that the meter is able to handle what it needs to, because some of them, if you hook a solar system up, it'll backfeed into the system and it will actually charge you for what you're producing.
Perfect. That's amazing advice. So as I was saying, basically to just take into account all of your expertise, Mr. Cool team and John from SolarSpace, what are the advantages of combining DIY-friendly HVAC equipment with a solar system?
Well, definitely on our side, it's cost and timing. You're
Okay.
taking out that professional installation, cost that's typically required for HVAC systems, but also timing as well, because then you can do it when you need it. A lot of times, especially during the busy season of the summer, your HVAC providers are busy as well, solving problems and installing new systems. If you're able to do a DIY system, you can order it, have it delivered, and possibly do it over the weekend.
Amazing. John, do you have anything to add to that on your
I mean,
side?
yeah, DIY, you definitely benefit from the panel straightforward, anything with specs and connection. So in that setting, it's just plug and play. You want to be able to have a micro inverter or some kind of a low voltage, so it doesn't really catch us on fire. I think that's the number one thing that I notice a lot is like understanding the voltage, right? Understanding how much power you're dealing with before you just connect everything together, because that's where the danger comes.
Perfect. Again, valuable advice. And guys, lastly, before we move on to the next section, where should homeowners draw the line between what they can reasonably DIY and what should be handled by a licensed professional?
Well, I think definitely you are your own marker when it comes to what you're possible, capable of. I know I keep myself in check as much as possible. That doesn't always work sometimes, but when that time comes, the great thing about it is that, any licensed professional can install our systems just the same if you need that additional help. We outline the steps to the installation manual. Like I said, we always recommend that some electrician hook up that final connection. But other than that, the process itself is pretty simple.
Perfect. Does anybody wants to add anything else to that answer to build up a little bit?
Yeah, like Shane said, you want to find a skilled technician that know what he's doing, right? You want to find a licensed electrician to do the proper work. I think, when you think about DIY for solar, it's really about assembling and putting it together and maybe connecting the wires. But once it comes to like turning it on and having it operating at a high performance, you still need to find a professional to oversee and make sure the quality control is there.
Amazing. And I'm going to introduce the second question of the webinar. The audience is asking, what efficiency can you plan for? Say a room AC consumes 1500 watts peak. How many watts of panels should you plan to have?
So you want to be running anywhere from like 400 to 430. At least I would say 12 panels each. So that way you're generating enough throughout the day to offset just that AC room. But if you're talking about the whole house, you're probably going to be offsetting about 20% of your usage throughout the day. So, if you have an EV car on top of that, or you're working at home, you're cooking at night. So those things will add on. So knowing exactly how much output, and then you can design the input and how much you want to generate. That is still the number one thing is learning how to net zero is the important goal in today's world, because you can't really benefit and make money off solar anymore. There's no feed-in tariff, there's no selling back electricity. They cut all that off like 10 years ago. So you really got to understand how to net zero your home and make it into a smart home nowadays.
Perfect, John. Thank you for that answer. And moving a little bit along to solar panel performance during extreme heat. People often assume that more sunlight automatically means better solar production, but what actually happens to solar panels when temperatures become extremely high?
Yeah, so more sunlight, it does increase more output, but more heat actually reduce how the panels will work because it won't work as good as it should be, just because a lot of these semiconductors are generating the voltage, but they're joining so hard that they overwork. So you're overworking the system just to produce the energy in that setting. And another thing you want to look for is probably the efficiency of the panel. Most panels are 20 to 21%. But the top tier panels that are manufacturing now are 24 to 28%. So the efficiency of the panel also has a higher long and higher life output, usually about 25 years to 30 years.
Okay, and what should homeowners look for in a panel specifications when they're located in a very hot climate?
Yeah, you want to be looking at the coefficient of the panel. You want to be looking at the FTC rating points, anywhere from 40 Celsius to 100 Celsius. So you want to look for those kind of settings. And on top of that, we go through a lot of testing here in Florida with our Florida Energy Solar Center. We put
Mhm.
all the panels there to originally test how heat, performs and how they really output as well. So we put tests to all our panels as well.
Okay, John. And for someone, let's say specifically designing solar around high summer AC consumption, what would you recommend they prioritize when selecting modules?
Yeah, you want to look for a low temperature coefficient, anything with like look at the spec sheet, look at how much temperature it can output and input. The lower the better, in my opinion. And you want to be having a lower panel wattage as well. That will also help reduce the heat to overwork the system. That way you're not really generating more power, but then you overwork the system. You're generating enough power, but you're underworking the system.
Okay, perfect, understood. And so now let's get to the part that I think really changes the conversation. What happens when the grid actually goes down? So I'm going to pass the ball a little bit to the Mr. Cool team here. Let's say a homeowner has solar, but the grid goes down. Will their AC automatically continue running? This is for anybody in the Mr.
On
Cool.
that is
Constellation,
the
definitely.
AC will come back on. It may shut down for just a few seconds as the power changes, but it depends on how it's hooked up. So if it's hooked up to where it automatically powers up, then yes, it'll continue running. All of our mini splits, they will automatically come back on to the setting that they were set at once they lost power.
Amazing. And in addition to solar, what more does the homeowner need to keep the cooling system operating during an outage?
Shane, you want to go ahead and take this one?
Well, it definitely, any of your non, as long as it's a backed up load, that's connected to, cable inverters and your transfer equipment and everything, then nothing, that's the critical load panel is probably often more practical than attempting a whole home backup, but it just depends. But as long as you have it hooked up to where it's going to be able to immediately switch over, then our AC systems will just take right over just to save it.
Perfect. And John, from the solar side this time, what role does the inverter play in making backup power possible?
Yeah, so it really depends on what kind of inverters. One of my favorite ones are Enphase. So Enphase has very low voltage. That way it's only 60 volt. And on top of that, it communicates back to the gateway to the solar system, and it can operate during that outage. So you're not really losing power. You're just communicating, still generating.
Okay, understood. And as to the battery, how does battery storage change what a homeowner can do during an outage?
Yeah, as in battery storage, you want to think about it as a rain barrel. You know what I mean? So in that setting, when you're throughout the day, you're gathering all this energy and it goes to the barrel. And when you really need it, you're just draining that barrel and using that kind of a power. But most places you live would not have an outage more than a few hours. But if you're in the country area, outskirt, you might lose the power for a few days, but it typically kicks back on.
Okay. And how should homeowners think about sizing their solar and battery system if their priority is keeping essential loads such as AC running?
So yeah, you like just like you want to be able to know your output and input. Typical like any heating system are typical about 40% offset. So if you want to just offset the AC units and keep it running, you want to design a system just 40% or 50% offset of the usage.
Perfect. Thank you for that answer, guys. And we're introducing the third question from the audience. They're asking, how would a Mr. Cool system work if it was connected to a larger battery backup system that are powered by solar? How large of a battery backup system would be required?
That would really depend on the size of the system that you're hooking up to.
Okay. Okay, maybe that's a good thing to have into account for the next question. Maybe the audience member wants to let us know the size of their system so that we can continue with that. In the meantime, I'll move along a little bit. So we'll try not to bore you as much with the technicalities of it all. but this is for both parties. Does a homeowner necessarily need to power their entire house during an outage, or can they design a system around critical loads?
I would design my
Yeah.
HVAC
system
side
around
of things,
critical
if you're
loads.
utilizing a DIY split series, system, where you're trying to operate, and heat and cool your entire home off of mini splits. The great thing about it is, well, they don't all have to be on. A standard duct system, your system's either on or off, regardless of whether you like it. With mini splits, you're able to choose which rooms you do have on at any time. So if there are certain parts of the house that you want to keep off during those peak times, then you can, and you can be able to do that and control more than what you would with a standard ducted system.
So, taking that into account, what would a realistic solar space plus battery plus Mr. Cool setup look like for someone living in a hot climate?
Yeah, you want a typical system would be anywhere from 15 to 20 panels, and then maybe a 12 kilowatt system with a mini split. I think that's typically a typical setup. In that setting, you don't really want to power the whole entire house. Your system is going to be draining like 2 hours, and then won't be able to sleep throughout the night. So in that setting, like Shane said, you want to specifically choose the load that you want or a specific room that you want to back up, regardless of the fan, septic tank pump, or even have the mini split or a couple of lights and internet, of course. And that setting, that's the load you want to be able to pick, not just the whole entire house.
Understood. And let's say for someone that wants to eventually become completely off grid, what additional considerations should they have?
Yeah, really depending on the size of your house and the size of the system. So, 5,000 square feet, you're probably looking at a 30 kilowatt system. You're looking at 1,500 square feet, anywhere with a 8 to 11 kilowatt system will do. And typically one battery could back up most stuff. But if you want to have a longer hour throughout the night and the AC running the whole entire night, you might want to think about two battery system here.
Fair. Amazing advice. And what is the biggest misconception homeowners have about solar and backup power?
I believe is solar is going to make me money. I'm going to save a lot of money. I think typically those are the conception, because solar does save you money in the long run, but it will not give you the ROI right away, especially if you're adding a battery system onto it, right? You're looking your ROI 15 to 16 year. With a solar system, you're looking maybe 7 to 8 year. So you're basically investing into your home that you're going to live there at least 15 years to get your money back. And having that kind of usage and understanding how much input and output is the most important part of any homeowners.
Perfect, John. Thank you basically for introducing the next topic, which is ROI. So thank you for touching that. We've talked about comfort and energy independence. Let's now talk about the financial side of it all. How should homeowners think about the long-term value of investing in solar when utility rates continue to increase?
Yeah, I mean, typically utility rates always going to increase 7 to 14% yearly. It doesn't matter where you live. You're always going to be paying more and more, especially once you get to the tier 2, right? So if anything under 1,000 kilowatt, you're going to save some money regardless. And that's the tier you want to keep. It doesn't matter if it's 50% or 100% offset. But once you get to tier 2, that's when things cost more. You're paying almost double, right? So you want to look for a system that can produce over 25 years. And on top of that, you want to find a liable contractor that will be there for you in those times, not just going to install it for you and you're done for the next 3 or 4 years. You can't help somebody help you fix your system.
Okay, perfect. So now I'll pass it along to either John, Chase, or Shane. How does upgrading to a more efficient cooling system affect the overall economics of a solar investment?
Well, at the end of the day, efficiency reduces the electrical load the solar investment has to serve. That means longer life longevity, smaller array or battery for the same goal. So, if an older AC is due for replacement, sizing solar around that older consumption may lock in more generational capacity than upgraded homes ultimately need.
Okay, and how do you think should homeowners calculate the potential ROI of combining solar with high efficiency cooling? This is for whomever.
Yeah, I mean, like I said, you want to be able to calculate your output and input. So if you're just not running energy efficient units or heat pumps, you're going to be draining more on toll on your system. You're going to be, dragging it and just keep running it 12 hours a day instead of maybe 4 or 5, right? So
Okay.
knowing how much your input and output is very important. And then having energy efficient unit in your home can save you a lot of money on top of that. You're not straining your whole energy load.
Understood, John. And let's say someone wants to be prepared for next summer. When should they realistically start planning?
Yeah, start planning now. Know how much energy your house use. Start looking at the electric bill, and that's the first step. Knowing that kind of graph, and then therefore now you can design your system accordingly. Do I need to maybe switch out windows? Do I need to upgrade, insulate the roof? Do I need to switch out some energy efficient units? Doesn't matter the heat pump or a hybrid hot water heater or a mini split or the whole house AC unit. So all these things play a huge role, and therefore, once we gather that information, the solar system can be designed up accordingly to your lifestyle.
Perfect. And I don't know if you guys remember the last question. We were missing a little bit of info. So the audience member just sent us, can the unit accept DC directly from solar panels or AC input only? He says, apologies, I haven't reviewed the tech specs. So how long do Mr. Cool systems typically last?
They last. It depends on how well they're taken care of, first of all. But if a generally maintained unit will last 15, 20 years. And then the first part of the question was, could you repeat that one?
Yeah, how would a Mr. Cool system work if it was connected to a larger battery backup system that are powered by solar?
It
He
does
said
not
how.
work off direct
Mhm.
DC. It works off of AC voltage, and then it converts it. It is converted to DC, but it's by a control board on the end and the inside the unit.
Correct.
Perfect. Thank you guys for answering that. Taking into account we're receiving questions from the audience, which basically they're going to be our customers. Taking into account the customer experience for both SolarSpace and Mr. Cool, what does the customer journey typically look like when someone decides to upgrade their cooling system? This is for the Mr. Cool team.
Well, definitely, evaluating what your situation is going to be important first, so starting with what kind of upgrade that you need to do, whether you're going to be upgrading for a whole ducted system and changing out what you existingly had, or if you're going to go one of the DIY solutions and do a mini split system instead. Looking at that, then being able to assess the home itself, what the requirements are for each of those individual zones or spaces that you're going to be cooling, and then getting with someone like A1 SolarSpace to be able to, plan the correct system where you're going to place your indoor units, based on where you're going to place your outdoor units, the line sets you need to connect those, and then getting all that put together into a good bundle so that way you can have everything you need when it comes time for that installation when it arrives.
Perfect. And what should homeowners realistically expect from a DIY-friendly Mr. Cool installation?
They should expect definitely you're going to need.
I think we lost you a little bit, Shane. I don't know if John wants to continue.
Yeah. So what you're going to need to look at is you got to have some a saw, hole saws to penetrate the wall for your line sets. So be aware that you're gonna have to use power tools to install this unit.
Okay, perfect. Thank you for that answer. And now moving a little bit to John, what should homeowners look for when selecting solar equipment in a solar provider?
Yeah, you want to be looking for tier 1 modules. You want to have
Tier 1.
a warranty on top of that. Most solar panels have a warranty of 25 years and possibly 30 years of coefficient. If anything happens to the panel, you're able to replace it. So those are the two main things. Is it a tier 1 module? Do they have a lot of testing with different third-party services? And are they able to withstand 25 years?
Perfect. So those are basically the questions they should ask when trying to purchase solar equipment or solar modules. And give me a second. What has surprised your customers most after combining energy efficient cooling with solar?
Yeah, I mean, just the surprising is you're gonna have a $30 bill, $35 bills. If you do it right, you're just paying for interconnection fee. That is the goal of it. You want to be able to understand your offset usage and having a smart home. Net zeroing, it should be your goal. Knowing how to manage that, managing your own solar system, right? And knowing how much input and output.
Perfect. And in following this line, what advice, this is for either John at SolarSpace or the Mr. Cool team, what advice would you give a homeowner that is interested in the concept, wants to start, but doesn't know where to start?
Yeah, I would tell them start with the load, not the equipment. Start knowing how much energy you use. What is the most thing that use the most electricity in your home? Is it your AC unit? Is it your hot water or your cooking appliances? Figure that out and then design it accordingly. If you need to switch those off, or you just need to add more power to power those units.
Okay, perfect. And on the Mr. Cool side, what would the advice be for the person that wants to start with the concept but doesn't know where to?
Definitely, same thing applies, understanding the load. So gather 12 months of electric bills, identifying your existing system and its condition, decide whether your goal is to lower bills or if it's outage comfort or eventually off-grid operation. Then determine, the right HVAC load first and take that post-upgrade demand to the solar designer. That sequence gives both sides something real to design around.
Perfect. So now I'm going to take a minute because we do have a webinar bonus for the attendees. We spent a lot of time today talking about preparing before the next heat wave rather than waiting until you're already dealing with high bills or an outage. And because we know that every home and solar or HVAC project is different, we wanted to offer something a little bit more personal as a bonus for everyone joining us today. We have a free technical consultation through August 31st. We're offering a free technical consultation, as I mentioned, with our engineer, Vasily Smirnov. If you're planning an upcoming solar or HVAC project and have questions about system sizing, equipment, compatibility, installation, or even how to put everything together, simply schedule your call before August 31st and bring your questions. Okay, so that's something we can offer for all the attendees today. I know we've covered a lot. You guys are left with a lot of information, but now we'd like to turn it over to the audience. If you have any questions about solar panels, Mr. Cool systems, batteries, DIYs, now is your time to offer or to ask any questions. We do have one for both teams. During operation under solar source, does the unit primary source solar, then draw from the grid if the solar is shaded?
No, typically you're gonna get rays, you're gonna get, sunlight throughout, even if it's cloudy. So think about you going to the beach, it's cloudy all day, you're still gonna get sunburn regardless. So in that setting, you're generating electricity. Yes, but if you overconsume, let's say you start, washing your clothes, cooking at the same time, turning your AC to 72, you would possibly will drain some from the grid. But once that basically average out, you're going to be putting more solar back into the grid. So think about net metering. You want to look at the meter. You're going to be using as more energy usage, but once you start producing more than you use, it's going to go back the other way.
And guys, let's say we have a customer that already has an existing Mr. Cool system. So can they add solar to it?
Yes, any typical system can be retrofit. You can always add more solar than you use. So, but the point is, you want to do one and done. You don't want to be touching the system as often as you need because you could maybe have more penetration on your roof. You might be more, more problems, more leak roofs. So in that setting, you just want to have it done right. Know exactly how much energy you consume, and then design the system accordingly to how much output you want.
Perfect. And same question, but the other way around for the Mr. Cool team. Let's say a customer already has a solar system installed. Can they add a Mr. Cool system?
Generally, yes. I mean, as long as the load is evaluated properly, then yes, just like current people do with their systems and change them out, you can do that so as well as your house, just the same with the Mr. Cool system.
Okay, perfect. And they were basically asking, what should I upgrade first? Solar, HVAC, or batteries?
I typically say go with any energy efficient unit first. Therefore, you're already saving money investing into your equipment and your home, right? After that, then it'll give you a true usage of how much energy you consume. And therefore, you really need a battery backup or net consumption or peak hour usage, then get the battery. Because once you add the battery, the ROI of the solar system and battery, it's just become higher longer years to get your money back.
That's correct, because if you end up, changing your system to where it doesn't need as much power as what it used to, then that may be the first thing that you want to do is upgrade that HVAC. So then you'll be able to properly size your solar system going forward.
The audience was also asking, and I think this is going to be our last question of the day, but what happens if there are several cloudy days?
Yeah, typically in multiple cloudy days, you will be draining from the grid. So you will be using some of the grid system, but it won't, like I said, as long as you keep it under 1,000 kilowatt usage, you're not going to be charged premium for your usage. And that's the goal at today's time. You want to be keeping under anything under 1,000 kilowatt usage. And on top of that, you want to be generating enough to offset. So the graph will always go up and down throughout the day, throughout the month. It doesn't matter because you will get end of the year, you're going to produce how much you're guaranteed to produce and use that output as well. So that's why knowing your system, knowing how much you input, knowing how much your output is very important. Certain month, you might pay a little bit more. Maybe, for example, instead of paying the interconnection fee, you might pay $60. You might use a little bit of energy, but you're still keeping it under 1,000 kilowatt usage.
Perfect, John. And this one's
And if
actually
it's
for you.
cloudy outside.
Yeah, John, go ahead.
And if it's cloudy outside, that means your system's not working that hard. So not as much strain on the whole overall.
Perfect. Good to know that.
Right.
And I actually lied with the last one being the last question. We have another one. They're saying for standalone solar, what size inverter required to drive the unit? A multiplier, kilowatt output per ton? It's in the chat if you want to double check the question.
So it really depends. For standalone battery, you want to be looking at least low voltage. I personally like the N-phase microinverters because I know exactly how much voltage are going into my system is low, and then I can generate accordingly to back to the AC. So typically anywhere from. Also, you want to look at the tonnage of the AC unit as well, right? Because you don't want to be over outputting and not really performing the way it needs. So typically anywhere from 4 to 6 kilowatt will do that if it's 3 to 4 ton usually.
Perfect, John. Thank you for answering that questions. Teams, SolarSpace, Mr. Cool, is there anything else you want to add? We're running a little bit out of time, so if there's anything you want to add to the conversation, something we forgot to mention.
We just appreciate the opportunity to be able to talk with everyone. And of course, if there's any questions going forward, feel free to always reach out. We're always here to help.
Perfect. So, John, thank you for joining us from SolarSpace, and thank you to the Mr. Cool team for sharing your expertise today. I think today's conversation really demonstrates that solar isn't just about putting panels on your roof and watching your electric bill go down. It's about creating an energy system that works around the way your home actually uses electricity. During a heat wave, your cooling system is one of your biggest energy demands. Fortunately, that's also when solar can be producing significant amounts of power. And when you combine efficient cooling from Mr. Cool with solar generation from SolarSpace, and where appropriate battery storage and the right system design, you can take much greater control over your energy costs and your comfort. Because solar isn't just about saving money anymore. It's about staying comfortable when everyone else is sweating through an outage. So I'd like to thank everybody again for joining us. Stay cool, stay prepared, and we'll see you at our next webinar. Thank you all so much.
Thank you, everyone. Thanks for having me.